Things could get weird faster than we can even imagine, like space-time itself is ripping apart. I'm a little worried because the night sky is changing fast. In just a few years, maybe decades, it might be hard to even recognize. Astronomers everywhere are starting to worry. People like Neil deGrasse Tyson said Polaris is about to blow up, and the story behind it is kind of creepy. Polaris, the North Star, has always been there, a point of reference for anyone looking up. It's helped sailors navigate, pointed the way for stargazers, and guided astronomers. But that might change fast, messing up our view of the night sky and how we take measurements. Let's look at how big of a deal this could be. Come along as we tell the story of Polaris as it goes out with a bang. For ages, Polaris has been a guide for sailors and astronomers. It's been super important because it's always there, but what if it disappeared? Back in September 2023, some astronomers presented a research paper that suggested this star might blow and may be vanishing from the night sky for good. Before we think about the effects, let's learn a bit about Polaris. Also known as the North Star, it's close to the North Pole of Earth. It pretty much stays put in the northern sky. If you find the Little Dipper, you can find Polaris. Polaris is a super big, yellowish-white star way bigger and brighter than our Sun. It's not alone either. It's part of a triple star system. Polaris A and Polaris B are like a pair, with Polaris B orbiting around Polaris A. The push and pull between these stars impacts how they behave and even how bright they are. But the exact details of how they mess with each other are still a mystery. Polaris is about 323 light-years away. That means the light we see started its trip over 300 years ago. So, if it blew up today, we wouldn't see it for another 300 years. It might have already happened. All through history, the North Star has mattered. It was a super major tool for ancient sailors. Polaris also stood with being dependable, a constant in a changing world. For astronomers, Polaris was a reference point, which helped them study other stars. Polaris is a variable star, meaning its brightness changes. Seeing how it changes has helped us learn about stars and how far away they are. Normally, the changes in brightness happen in a regular way, but lately Polaris has been acting weird. Instead of following its normal pattern, it's been dimming and brightening all over the place. That's why some scientists think it's getting close to the end. The time it takes for Polaris to brighten and dim is getting longer, by about 4 or 5 seconds each year. It might not seem like much, but it's a big deal for astronomers. Some think the stars are pulling on each other, affecting how it pulsates. Other astronomers think it's getting ready to blow. Similar to what's been going on with Betelgeuse. NASA is watching Betelgeuse, but they aren't watching Polaris as closely. When a giant star is about to die, it goes through stages, finally ending with a big explosion called a supernova. Because of how Polaris is acting, some scientists think it's fusing helium like other stars that are near the end. But there's no firm proof yet. Astronomers are studying these changes to figure out what's up with Polaris. If Polaris goes supernova, it would be pretty cool. Could be brighter than the moon for days, weeks, or even months. It would change how we see some constellations. But don't panic, Earth would be safe because it's far away. If Polaris blew, it wouldn't be as awesome as Betelgeuse, but we could still see it explode by the naked eye, and it would be brighter than the nearby stars. Scientists would lose their minds. But it wouldn't affect Earth too much. What happens to Polaris if it blows? Well, actually, Polaris isn't big enough to go supernova. If a large star ends its life this way, it means a complete meltdown of its core, triggering an intense shock wave that causes the star to explode violently instead. It will lose its outer layers and turn into a white dwarf. A white dwarf is what's left of a small star that has run out of fuel. It's super heavy, almost as heavy as the Sun, but squeezed into the size of Earth. Once that happens, we won't be able to see it anymore. Looking at past supernovas can help us guess what will happen with Polaris. By comparing it to supernovas such as SN 1054 or SN 1987A, and more recent explosions can give us a bigger picture. For example, SN 1054 created the Crab Nebula, which is expanding and sending out radiation. SN 1987A gave us info on how elements are created and how supernova remains work. Looking at stuff like nebulas, cosmic rays, and brightness can tell us more about Polaris. Nebula form when the stuff from a supernova mixes with gas and dust. and cosmic rays, which are particles that are superfast and come from the supernova's shock wave, affect space. To compare Polaris's expected burst with other supernovas effectively, scientists look at the amount of mass, what it's made of, and how fast it's moving. They look at the light, the colors, and what's left to estimate what might happen with Polaris. They also ask themselves questions like, could Polaris's explosion create a nebula, or will there be some different elements created? Another important study is how stars pulsate or change brightness as they die, just like Polaris. Comparing these to past supernovas can show similarities and help us know more about how it might explode. Even after all this work, astronomers are still scratching their heads about Polaris. Finding out what's making it act so weird is important for learning about how stars evolve. Figuring out why Polaris pulses strangely will mean scientists from different fields working together and developing new theories and ways to watch the stars. If we lose Polaris as our North Star, it will create issues in the astronomical world. We would have to change how our telescopes work, and it would mess up measurements. It might also affect things like navigation and traditions that rely on the stars. So, this is why this event is pretty important to us. The mystery of Polaris shows that we need to keep researching. Astronomers have to deal with tough questions about how it's pulsing and find solid answers. Ultimately, Polaris's future is uncertain, and we have to wait and see, but our curiosity will always drive us to learn more about the universe. The likely end of Polaris raises some curious questions of the future of other celestial bodies across the cosmos. As we watch these changes, it reminds astronomers that the universe is unpredictable. Stars like Polaris and Betelgeuse are just a couple of stars among many that change dramatically, offering insight of how stars evolve. There are many other stars evolving through comparable phases, with some nearing the end of their lives that indicate big transformations are coming. Several red giants, for example, show signs of instability with differences in irregular pulsations and brightness. This can indicate that the star is running out of fuel to use. These stars are a laboratory for scientists looking into the supernova and stellar explosion phenomena. Besides looking at individual stars, researchers study star clusters where many stars change in some way. How these stars connect shows us that there are environmental factors that shape how they live. Within these groups, there are dynamic elements like forces of gravity or mass that can affect how a star behaves, which may shift how stars evolve. Studying supernovas and the remains left behind offer a lot of information about space. When massive stars explode, they throw a lot of elements into the universe. This material helps create new planets and stars, which highlights the interconnectedness behind it all. The remains of supernovas are often seen as nebula, which act as stellar nurseries for stars that are being born. By watching these actions happen, scientists can connect the dots. The results from stellar explosions can do more than affect the area immediately. These supernovas can shift star creation rates, impacting the creation of entire galaxies. The waves these explosions create can compress clouds, triggering new stars to be born. This means that the lifetime of a star can affect many things throughout the cosmos, influencing the development of galaxies for billions of years. As space telescopes get better, astronomers are more equipped to monitor cosmic events. They use instruments to gain detailed images and data of stars that are far away. Scientists use this to create models of stellar evolution, and machine learning is playing a role by allowing researchers to see patterns in data. Throughout history, space activity has had a hold on navigation, culture, and mythology. The North Star has stood as a symbol of guidance. As we evolve, we value how space has a hold on us. For ages, Polaris has helped people at sea and scientists find their way. It's been a reliable light in the sky. But that might be ending. Back in September, some people from the Royal Astronomical Society put out a paper that made it sound like Polaris is about to go boom, and it could vanish from the sky. Before we get into why that is a huge deal, let's talk about what Polaris is. It's also called the North Star, and it's special because it's almost right above the North Pole. It doesn't move much in the northern sky. You can find it in the Little Dipper. It's a pretty bright, yellowish-white giant star, way bigger and brighter than our sun. It's not alone either. It's a set of 3 stars. Polaris A and B go around each other, and there's another one circling them. They pull on each other, and that changes how they move. If something messes with that, the stars might get brighter or dimmer in weird ways. But nobody knows exactly what's going on. Polaris is pretty far away, like 323 light-years. That means the light we see now left over 3 centuries ago. So, if it blew up today, we wouldn't know for over 3 centuries. It might have already happened. The North Star has always been important to us. It helped old-time sailors get around, and it stood for being steady in a changing world. Scientists used it to study how things move in space and watched other stars that change. Polaris changes in brightness, and that helped us learn about stars. This helped us figure out how far things are in space and set up our tools. It usually does this in a way we can guess. But lately it's been acting strange. Instead of being steady, it's getting brighter and dimmer all over the place. Scientists worry that it's getting close to the end. This is something you see when stars are about to die. Polaris's pattern of getting brighter and dimmer is getting longer, which might not sound like much, but it's a sign. That might be caused by all the pulling and pushing between the stars. But some are really concerned and think it's about to explode. It's acting a lot like Betelgeuse, a star in Orion. That one's also been getting brighter and dimmer strangely, and people are scared it will pop. NASA is keeping a close eye on Betelgeuse, but not so much on Polaris. When a big star is almost done, it goes through several stages, like becoming a giant. Scientists think Polaris is in that stage now because it's doing weird things with its energy. These things are similar to other stars that are almost done. But we don't know for sure if it will blow up. Scientists are trying to figure it out. If Polaris went supernova, it would be awesome. It would probably be brighter than the moon for weeks or months. It would change how we see some groups of stars, like the Big Dipper. But don't worry, Earth would be fine since it's far away. While that Polaris explosion might not be as bright as Betelgeuse, it would still be easy to see and brighter than other stars. Space scientists and stargazers would be all over it. It wouldn't change Earth too much, though. What about Polaris itself? What will happen to it after all of this? Well, remember those stars that are big often end as supernovas, but that's not what is going on this time. When a big star blows up, it's like a crazy, final moment. It completely falls in on itself, causing a big burst of energy. Polaris isn't big enough for that. Instead, when it burns up all of its fuel, it will lose its outer layers and turn into a white dwarf. It won't be a supernova, but a quiet ending. A white dwarf is what's left of a smaller star. It's super dense, like the sun squished down to the size of Earth. When it happens, we won't be able to see this planet from here in our location. Looking at how other stars have blown up tells us a lot about how stars live and die. If we imagine that Polaris's other similar events like SN 1054 or SN 1987A and things that have happened more recently, it shows us what might it look like. For example, SN 1054 left behind the Crab Nebula, which is still getting bigger and sending out all kinds of energy. SN 1987A showed us how elements are made and how supernova bits move. If we watch what happens when stars make nebulas, shoot out energy, and change in brightness, we can learn more about Polaris.